Hello, everyone, and welcome. And today we are embarking on a journey through the vast expanse of the cosmos, a realm of wonder, mystery, and constant change. For decades, the prevailing picture of our universe has been one of the relentless expansion, a concept firmly rooted in the Big Bang theory and reinforced by the countless observations. We have learned that not only is the universe growing, but that this expansion is actually accelerating. The culprit has been a mysterious force we call dark energy because we don't understand what this energy is all about. So, we call it dark energy. But if this is this view has to change, if this picture is starting to change, what if the engine driving this accelerating universe is spurting, weakening, and perhaps even threatening to reverse course? Could the universe, after billions of years of outward growth, begin to shrink? And this is the enigmatic dark energy to be blamed. That is a question that we want to address today. So today we are going to delve into this fascinating and potentially mind-bending scenario: the possibility of a shrinking universe and the role of the dark energy that it might play in bringing about the dramatic cosmic U-turn. Our understanding of the universe's expansion began with the groundbreaking work of Edwin Hubble in the 1920s. By observing the distant galaxies, Hubble discovered that they were moving away from us. And the farther away a galaxy was, the faster it was receding. This relationship was known as the Hubble's law, and it's also known as the Hubble constant. And this law provided the first observational evidence that the universe is not static but dynamically expanding. The Big Bang theory emerged as the most compelling explanation for the expansion. It positions that the universe originated from incredibly hot, dense state and has been expanding and cooling ever since. Over time, gravity, the dominant force on larger scale, began to pull matter together, leading to the formation of stars, galaxies, and large-scale structures we observe today. For a long time, scientists believed that the expansion would eventually slow down due to gravitational pull of all the matter in the universe. The ultimate fate was thought to be either a big freeze where the expansion continues indefinitely, or it or expansion, or the big crunch, which basically have the gravity eventually overcomes the expansion, causing the universe to collapse back into the incredible dense state. The amount of matter in the universe was believed to be the deciding factor. However, in the late 1990s, a revolutionary discovery shook the foundation of cosmology. Two independent teams of astronomers studying distance type 1A supernovae, which are stellar explosions. We know that serves as a standard candle for measuring cosmic distances, found something unexpected. These supernovae were fainter than they should have been if the universe expansion was merely slowing down. In fact, they were farther away, indicating that the expansion of the universe was not decelerating but accelerating. This astonishing finding implied the existence of some of the mysterious force counteracting gravity on a larger scale, pushing galaxies further apart at an ever increasing rate. Scientists dubbed this enigmatic entity dark energy, and the term dark signifies that we cannot directly see or interact with it through electromagnetic radiation. It doesn't emit, absorb, or reflect light. We only know of its existence through its gravitational effect on the expansion of the universe. The nature of the dark energy remains one of the biggest unsolved mystery in modern physics. The leading theoretical explanation is the cosmological constant, a concept originally introduced by Albert Einstein into his theory of general relativity. He later discarded it, but it resurfaced as a possible explanation of dark energy. The cosmological constant represents a constant energy density inherent in the vacuum of space itself. As the universe expands, more space is created and thus more dark energy comes into being, leading to accelerating the expansion. Another possibility is the quiescence, a hypothetical dynamic field that changes every time. Unlike the constant energy density of the cosmological constant, the different models of quintessence predict different behaviors for dark energy in future. So, if dark energy, as we currently understand, especially in the context of the cosmological constant, continues its relentless push, the ultimate fate of the universe is likely to become a big rip. In this scenario, accelerating expansion continues indefinitely and even intensify. Eventually, the repulsive force of the dark energy would become so strong that it would overcome all the other forces, first tearing apart galaxies, then solar systems, then individual stars and planets, and finally, even atoms and subatomic particles, leaving behind the cold, empty void of fundamental particles flying apart. But what if our understanding of the dark energy is incomplete? What if, instead of being a constant or an ever increasing force, dark energy is actually dynamic and its strength is changing over time? Recent research and ongoing cosmological surveys are beginning to explore these very possibilities. One of the key tools in this investigation is the Dark Energy Spectroscope Instrument, or DESI. DESI. This ambitious project is mapping the positions of velocities of millions of galaxies across the significant portion of the sky, providing unprecedented detail in three-dimensional maps of the universe. By meticulously analyzing this fact, we better understand of the history of the universe and expansion and behavior of the dark energy over cosmic time. If the data from DESI and other future experiment reveals that the rate of the universe acceleration is actually slowing down, or even the expansion itself is decelerating, it would have profound implications of our understanding of the dark energy. It would suggest that dark energy is not a constant force and its influence might be waning away. If the dark energy was indeed weakening, the gravitational pull of all the matter and energy in the universe, which has been fighting a losing battle against the dark energy for billions of years, might eventually regain dominance. If gravity were to overcome the outward expansion, the universe would begin to contract. This contraction would then accelerate over time, eventually leading to a catastrophic collapse known as the Big Crunch. In the Big Crunch scenario, galaxies would begin to rush towards each other, the cosmic microwave background radiation would heat up, and the density and the temperature of the universe would increase dramatically. Eventually, all the matter and energy would be compressed back into infinitely hot and dense singularity, perhaps similar to the state from which the Big Bang originated. The idea of Big Crunch has a certain poetic symmetry to it, suggesting a cyclic universe where expansion and the contraction follow one another. However, it's crucial to emphasize that this scenario is highly speculative at this point. The current evidence strongly support an accelerating expansion driven by the dark energy. Possibility of the dark energy weakening is still very much an open question, and more data is needed to determine the true fate of our universe. The question of whether our universe will continue to expand forever or eventually succumb to Big Crunch hinges upon the mysterious nature of the dark energy. While the current accelerating expansion, the possibility of dynamic dark energy could be eventually lead to a cosmic contraction remains a fascinating and actively researched area of the cosmology. Ongoing and future astronomical surveys like DESI are crucial for shedding light on this fundamental question. By precisely measuring the expansion history of the universe, scientists hope to unravel the secrets of the dark energy and determine the ultimate destiny of our cosmos. Further, we face a gradual big freeze, a violent big rip, or big crunch, uh, or a dramatic reversal into big crunch. The universe continues to surprise and challenge our understanding. The quest to comprehend its evolution is the testament to human curiosity and our relentless pursuit of knowledge about the grandest stage of all. So, friends, thank you for joining me on this cosmic exploration. Until next time, keep looking up, and I look forward to receiving your comment about your thoughts about what is the fate of our universe. Leave your comments in the comment section below. And have a nice week ahead, and I will catch you again in the next one.